In late February, skies around the world will host a conjunction involving 6 planets of our solar system, all strung like pearls along the imaginary line of the ecliptic. It will be the most accessible astronomical event of the year, and unlike the alignments of 2024 and 2025, inconveniently occurring before dawn, this one will happen in the evening, after dinner, when most people are still awake and willing to step outside. Will this be some sensationalized clickbait event announced as a harbinger of cataclysms or disasters? No, it will bring only beauty. And that's why we invite you to watch this video, created with the intention of helping you appreciate a small, hidden magic of our sky. Those of you old enough may remember the fuss made in the 1970s about a planetary alignment predicted for March 1982. 2 astronomers had written a book, The Jupiter Effect, claiming that the configuration would cause catastrophes, including a devastating earthquake on the San Andreas Fault. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto would all be gathered within an arc of 95 degrees, and this, according to the authors, would unleash the end of the world. While some took the predictions seriously, others marked the date with end of the world themed parties. They were right to laugh it off, because of course nothing happened. The gravitational influences of the planets on Earth are in fact absolutely negligible compared to those already exerted by the Sun and Moon. If the Moon's gravitational pull causes a tide of about 6 feet, when the Sun's pull is added, twice a month, the tide increases to about 10 feet. To these 10 feet, the combined force of all the planets would add at most 4,000 of an inch, 0.1 millimeter. Venus, the planet closest to Earth, exerts a tidal force 30,000 times weaker than the Moon's. Jupiter, the most massive planet, 1/200,000 times weaker. Even the combined effects of all the planets on the Sun would be irrelevant. Their total mass is just over 1,000th of the Sun's, and their gravitational tug-of-war would produce at most a solar tide of 2/100ths of an inch. Okay, now that we've cleared that up, let's remember that the solar system is composed of 8 planets, which in order of distance from the Sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The first 4 are rocky bodies. Jupiter and Saturn are called gas giants, while the last 2 are ice giants. And just to give you an idea of what we'll be looking at when we turn our noses up to observe the sky, let's also remember that Mercury's average distance from the Sun, for example, is just 36 million miles, 58 million kilometers, while Neptune orbits at an average of 2.8 billion miles, 4.5 billion kilometers. Earth is about 93 million miles, 150 million kilometers from the Sun, what astronomers call an astronomical unit, AU. And then there are the stars in the background. To avoid scaring you too much, we'll just say that Sirius, the brightest star in the sky and one of the closest to the Sun, is over 50 trillion miles, 80 trillion kilometers away from us. We remind you of all this to better frame the celestial phenomenon that you'll be able to admire these days, absolutely free, from wherever you are in the world. A bunch of planets all in the same region of sky. Planetary alignments in the solar system are phenomena that occur periodically due to the planet's different orbital speeds. The inner ones move faster and also have less distance to travel, while those from Jupiter outward move increasingly slowly as a function of their distance. So you can witness, as in a cycling race on a velodrome, a continuous chasing and overtaking, a continuous forming of groupings and thinnings. When only 2 planets are involved, it's called a conjunction, while we speak of a planetary alignment when 3 or more planets, as seen from Earth, appear more or less in the same region of sky. There's another fact that those who venture outside to observe this phenomenon will notice. The planets won't appear grouped in a disorderly fashion, but will line up one next to the other. This happens because planetary orbits, unlike those of comets, all lie, or nearly so, on the same plane, the ecliptic, which is the same plane on which Earth orbits. And precisely for this reason, the planets participating in the alignment seem to arrange themselves roughly in a row along an arc of several dozen degrees, and can all be observed over the course of the same night. Just a moment, guys. only 13% of subscribers know when we publish new videos. Make sure you subscribe and turn on the notification bell, because without it, you'll miss formats and documentaries you won't find anywhere else.
Alignments can be classified based on which and how many planets we can observe, and how wide an arc they're distributed across. For example, in the Great Alignment of 1982, the planets, as seen from Earth, appeared enclosed in an arc of about 95 degrees. A cosmic event of this type is very rare, occurring on average about every 175 years. But other alignments, with fewer planets or with planets distributed across a wider arc, have occurred in subsequent decades as well. It's important to emphasize that alignments are a perspective effect, depending on our point of view. While from Earth we'll see the planets apparently aligned, an observer outside the solar system would see them scattered in different directions. But since our eyes can't give us a three-dimensional view of the sky, everything, planets and stars, will seem to be at the same distance, as if hanging on a crystal sphere. It's an illusion, but a magnificent one. The alignment of February 2026 will involve 6 planets: Mercury, Venus, Saturn, Neptune, Uranus, and Jupiter, distributed across an arc of about 100 to 130 degrees.
Mars won't participate. It's on the other side of the Sun and will only be visible before dawn. But the special thing about this event is that it will occur in the evening, making it much more accessible than previous ones. The alignment will be visible from February 20th to March 5th, but the evening of February 28th offers the best conditions for observing all the planets. If possible, start observing right after sunset, around 6:30 p.m. This is important because Mercury, Venus, and Saturn, the westernmost planets, will be low on the horizon and will sink closer and closer to the edge of the sky as the evening progresses. Mercury in particular will set early. If you wait too long, you'll lose it. For the best view, choose a site with a completely unobstructed western horizon: a beach, an open field, a hilltop parking lot. A building or a row of trees in the wrong direction will steal the low planets from you. Let your eyes adapt to the dark for 20 to 30 minutes, and above all, avoid light sources of any kind. If you check your phone every 5 minutes, you'll ruin your retina's adaptation and see less. Planets can be distinguished from stars by their light, which doesn't twinkle. Stars shimmer because they're practically point-like, and atmospheric turbulence easily scrambles the thin thread of light reaching the observer's eyes. Planets appear instead as small disks, though too small to resolve with the naked eye, and their light remains much more stable. That said, let's imagine we've arrived at the fateful evening of February 28th. What will we see? Well, first of all, the breathtaking beauty of the winter sky, crowded with constellations stretching from the western horizon past the southern meridian. Celestial regions and objects that have made the history of astronomy. The most elusive of all planets, Mercury, will be low on the western horizon, immersed in the residual glow of sunset at about 5 degrees altitude. It's the hardest planet to observe in the solar system. It orbits so close to the Sun that it's visible only during brief windows, always in twilight. So much so that even many astronomy enthusiasts have never managed to see it. Despite such difficult observing conditions, this time you'll be helped by the fact that Mercury will be to the right of Venus, no more than 4 degrees away. In late February, it will shine at a magnitude around plus 1.6, making it about 150 times fainter than Venus. You'll have to be quick, because you'll have perhaps 15 to 20 minutes to spot it before it's lost in the haze of the horizon. On the evening of the 28th, Mercury will be about 68 million miles, 110 million kilometers from Earth. Venus will be low on the western horizon, but brilliantly bright, at magnitude minus 3.9. It will be the brightest object in the sky after the Sun and Moon, 10 times brighter even than Sirius, the brightest star. When the sky is still light and no other planet is visible, Venus will already be there, a small beacon of white light punching through the twilight. A small telescope will reveal its phase. During this period, it will appear as a crescent, similar to a waxing moon. Venus will be about 145 million miles, 234 million kilometers from Earth those evenings. A few degrees above and to the left of Venus, you'll find Saturn, with its characteristic pale straw yellow color. It's much less bright than Venus, magnitude 1.0 or so, comparable to a medium bright star, but steady and non-twinkling, which distinguishes it from nearby stars. Binoculars will let you spot Titan, its largest moon, while a small telescope will reward you with the spectacle of its rings, though during this period they'll be visible almost edge-on, which makes them less spectacular than usual, but offers the bonus of a very unusual view, the planet's disk completely naked. Saturn will be about 970 million miles, 1.56 billion kilometers from Earth those evenings, almost 11 times the Earth-Sun distance. Very close to Saturn, 1 degree to its right, is Neptune, but at magnitude 7.8, it will be completely invisible to the naked eye. You'll need binoculars or a small telescope, and even with optics, it will appear as a bluish dot, indistinguishable from background stars if you don't know exactly where to look.
The interest is more conceptual than visual. That dot is 2.9 billion miles, 4.6 billion kilometers away, and its light takes 4 hours to reach your eyes. Climbing higher in the sky, you'll find Uranus in the constellation Taurus, just over 4 degrees below the Pleiades. It will be about 60 degrees above the horizon, so in a much more comfortable position for observation. Uranus will have a magnitude of 5.8, technically at the limit of naked eye visibility, but in practice, you'll need binoculars to spot it as a tiny dot with a slight bluish tinge. Uranus at that moment will be about 1.83 billion miles, 2.95 billion kilometers away, 20 times the Earth-Sun distance. The king of the evening, however, will be Jupiter, about 55 degrees high to the southeast in the constellation Gemini, near the stars Castor and Pollux at magnitude -2.4. It will be the second brightest object in the sky after Venus. In the middle of the sky, it will be a commanding presence all night long, with its yellowish-white light that doesn't twinkle, that remains fixed and majestic while the stars around it shimmer. Impossible to mistake for anything else. Those evenings, Jupiter, fresh from its opposition on January 10th, will be about 428 million miles, 688 million kilometers from Earth. Even just binoculars will let you see the 4 Galilean moons, Io, Europa, Ganymede, Callisto, arranged like little beads on either side of the planet's disk. They change position night to night, sometimes hour to hour. On February 27th, the waxing crescent moon, 60% illuminated, will pass about 4 degrees from Jupiter. Okay, we've already said it. This alignment won't be as spectacular as a total solar eclipse, where day turns to night and the solar corona is revealed. There won't be shooting stars, there won't be supernova flashes, the planets won't move perceptibly over the course of the evening. Their movements are measurable on scales of days, not minutes. But if you can look at the sky with an awareness of the different depths you're observing, Mercury at 8 light minutes, Venus at 12, Saturn at 1.5 hours, Neptune at 4.5 hours, well, I assure you, you'll feel a spark of wonder all the same. All you need is a clear horizon to the west, a pair of eyes, and the willingness to stand outside in the cold for a while. Okay, guys, where will you watch it from? Let me know in the comments. And if you want to learn more, check my particular video that talks about other past alignments.